Hi everyone, I'm Alex Vanyo, Android Developer Relations Engineer, and today I'm going to be talking about adaptive layouts in Compose. I'm going to talk about what adaptive layouts mean, specifically for Compose, what makes adaptive layouts seem a bit tricky at first. Then I'm going to do a bunch of live coding to walk through some examples to see how to build these in Compose effectively. So let's start with what adaptive layouts are. So at this point in time, everyone's probably familiar with elements that stretch, responsive. We've gotten out of the realm of just hard coding a specific size. Things with weights and paddings and your containment will stretch a little bit. But as window sizes continue to change more and more, we need to go beyond that to get a really good user experience. Instead of having a navigation bar at the bottom, you might be swapping that entirely for a different component on the side, a navigation rail or a navigation drawer. And similarly, instead of just showing a list or a detail, you may want to show both. But this means that your layouts are showing different components depending on the window size, which is a little bit trickier to do than just having something that spreads a bit wider or shrinks with a weight. So in order to explain a little bit more about how that exactly is a bit trickier in Compose, let's do a brief refresher of Compose's phases. So Compose has 3 phases to render UI. The first is composition. This is where your composable calls are made. Second is layout, which gives you the measurement and placement, and with constraints passed through the system, actually lays out where everything is in your UI. And the final phase is drawing, and this actually is where your components become renderable things that the user actually sees. So from these 3 phases, there are 4 rules that we get out of these phases for how you build UI in Compose. And I'm going to go through 4 of these and think in your head about how all of these you kind of want to be true. Each of these is very useful. Unfortunately, they all can't be true at the same time. So the first desirable thing is to have first frame correctness. So this means that your desired final state of your UI is displayed correctly on the first frame without needing any additional frames to settle. This is good because you obviously want your UI to be correct and correct as soon as possible. Another thing that with adaptive layouts where you want to be showing different components that you want to have is you often want to call different composables. So this is changing the composition. You want to have different composables be called depending on the state of your UI and the window size. Another thing that often comes up in designs is you want to be using the local sizing information. So you want to be using the constraints, the size, how much space you have available at a specific part in your UI based on everything that's around it. And the last thing that's nice to do is avoid subcomposition. I'll talk a little bit more about the performance impacts of this later, but it's nice to not have to need to use subcomposition in order to achieve a specific UI design. So all of these are good things, but unfortunately, all 4 of these can't be met at the same time because of how the phase system works. So let's take a closer look at why all 4 of these can't be true together. So first frame correctness. In order to have the first frame be correct, there can't be any backwards writes. A backwards write happens when a specific phase is influenced from later phases. Because they're later phases and they happen after, in order to actually have it influence an earlier phase, it means that there has to be a second recomposition that happens, which often means that there's a second frame until your UI actually displays correctly. So in order to achieve first frame correctness, where it's correct right from the beginning, you can't have any of these backwards writes. Composition can't depend on layout, layout can't depend on drawing, and composition can't depend on drawing. And this is unfortunate for the second thing that we often want to do, which is changing composables. In order to have a first frame be correct, whatever's in that initial composition step has to be what we want to show. If you wanted to change that based on the layout or drawing, that would be a backwards write, so we can't change what's in composition and still have the first frame be correct. And specifically, we get local sizing information, constraints about what we can fit in the size we have available during layout. So we don't have information, we don't have access to that information yet in the initial composition. And there is a way around this, and that is subcomposition. So subcomposition falls into the layout phase and happens after you know the measurement and placement, and you can do extra compositions at this point. So this works. This gets around first frame correctness problem, but there's a performance impact to doing this. because you're delaying some of this composition until the layout phase when you know how much space is available. So all 4 of these can't be true, even though we might like them to be. So how do we actually achieve adaptive layouts? How do we turn a design that we're given into something that actually works and meets all these criteria, or most of these criteria? And the answer for that comes in these 4 things. If all 4 can't be true, as long as we can choose one to not be true, we can implement the rest and get a UI that works. So for all 4 of these, we have an option to break that rule, make it be false, and then we can get the rest. So let's go through what that actually means. So instead of having the first frame be correct, we could allow the first frame to be wrong. This is probably the worst option, because your first frame is now wrong, and this has a lot of kind of side effects and weird behavior that I'll walk through in some code. The second one is not allowing the composition to change. If we always can use the same composable piece of content, always the same things being called, then we're fine, because we can have layout and measurement happen to whatever's being composed if that's not changing. The other option is a lot of designs don't actually need local sizing information for getting a specific effect. If you can use your window level sizing information, that is something that is available at the first composition time. So again, there's no issue here. We can choose different composable contents as long as it's based on stuff that isn't the local sizing information. And finally, the 4th option is to use subcomposition. That gets us kind of out of this loop, but as I mentioned before, it can have a performance impact that you need to be careful of. So let's look at the first one, allowing the first frame to be wrong. And I'm going to dive into Android Studio here to show how this can lead to some strange effects. So the code here has a box with a white background, and then we're going to show a text and a spacer behind the text that we want to have colored red. We want to have it match the size of the text. And how this is working right now is we are getting the text size from the text layout. We're then storing that up here, and then we're sizing the spacer with that text size. But this is a backwards write, because this line decides the spacer is happening in composition. And the text layout here only will happen during layout, once we actually know how much space is available to render and render this text, and specifically in measurement. So we have the first composition will have this size be 0, because that's the initial state here. Then text layout will happen as we measure for the first time. Then text size will be updated, and only on the second frame will the spacer assume the correct size. Now, this can be a bit deceiving, because if you go into like a preview or you run it on a device, everything might look like it's working correctly. It settles into the desired state at the end. Oh, did that? Did my emulator crash? Of course, right now. Let me try a different one. Hope this works in a moment. Maybe if I stop everything. All right, maybe I'll skip that. But you can kind of see it actually in this preview. Maybe if I go into interactive mode, where there's a white flash there. Hopefully that shows up. The first frame ends up not having this a red background, and instead we see the white shine through. And what this can look like, whoops. This, if is in a bigger part of your UI, there might be a flash. There might be some weird UI artifact that happens on that very first frame, and then it ends up being correct, but that very first frame looks janky. So in this case, we can fix it by not having this backwards write. And in Box, there's a match parent size modifier that if we add, we can then skip the text layout. We don't have to have this backwards write. And then this will get the same effect as before, as it settles, with the spacer matching what the text size is, having the red background behind the box, and everything will be correct. So the end result is the same, but what this also means is that the first frame is also correct. So this is what first frame issues can look like, is some flash or some weird artifact for one frame as everything kind of settles in. This can also get worse if this is happening in more than one place. So this is an example where we have second frame content, which is again doing a backwards write to only show the content once it has been placed once. So the very first time this is composed, the content won't be placed because it is placed as false. Then placement will happen, this will become true, and then on the second and subsequent frames, content will actually be displayed. Now, this is a bit of a contrived example, but if you nest this, where you have second frame content happening in nested cases, we're gonna not have the correct output until the 1, 2, 3, 4, 5, 6, 7. Seventh frame will actually be kind of our final correct situation. Is this working? Did my emulator finally work or no? Hey, it finally worked. Okay, so it results in the final correct UI. It's showing the green background, which was the final background that we have here. But if I resize this and flashing warning, when an activity is recreated, we'll get this flash of all the backgrounds happening because it now is taking multiple frames to resolve. So anytime you have a first frame correctness issue, it can kind of cascade throughout your app because for some frame it might be incorrect, and if then some other piece of UI is depending on that, it might not be wrong for the first frame, and so on and so forth. Anytime you have animations that might be interacting together, or shared element transitions, or look-ahead layouts, anything that's more complex that it wants to know what the actual UI is, once you start introducing first frame correctness issues, that kind of cascades, and you might get really weird behavior, even if it finally ends up looking correct at the end. So that's the first option, allowing the first frame to be wrong, which you should probably avoid. But it's natural to kind of start here. Anything with unplaced, unglobally positioned, on text layout, all these things can introduce first frame correctness issues if you have backwards writes. So let's now go to the second option, and this is actually number 4. I'm going in order from worst to best. And that is using subcomposed layout or box with constraints. You can use subcomposition. So if I go over to subcomposition, what this gives you is with box with constraints, in composition, you get access to the max width and the max height. So in composition, you can now do if statements. If max width is greater than some available space, and this is local, like wherever this box with constraints is, that's how much space you have available to work with. So this allows you to call different composables within composition because it's kind of in that intermediate composition step as part of layout. So this works. This will give you the correct thing on the first frame, but the issue here comes down to performance. In order to achieve this by deferring composition until we have the layout and measurement step, we're deferring everything that's happening in that composition until right when we're trying to lay out our UI. And the issue here is, what if I have my entire app in here? What if everything that I'm doing in composition in my app is part of subcomposition? I'm now having to run everything that I want to do in composition into this very short time window to render a frame in between once I know how much space I have and when I'm trying to draw it. So like anything performance, you have to measure it. You have to check if this is actually a problem. In a lot of cases, subcomposition is fine. That's how lazy column and other things like that work. But you have to be careful because if you use it too much, and in cases where you don't really need it, you can run into performance issues. So again, measure it, see if it's a problem for you, but know that subcomposition can run into performance issues. It's not the magical solution. So the two more options you have, and one is to use the window level sizing information. And like I mentioned earlier, this bypasses kind of all the issues because it's stuff that we have during composition time that's not based on the local size information. So this is how the navigation suite scaffold and list detail pane scaffold for Material 3 Adaptive, newly released in beta, work. So the navigation suite scaffold, which will show a navigation bar or a navigation rail depending on Oops, I left this as not compiling. Based on the available window size, so it will swap to navigation rail or navigation bar, depending on the size of the window. In order to achieve this, it has a layout type. And the default value for this is calculating from the current window adaptive info, which gives the current size of the window and then runs a bit of logic to decide which one to use. So because this window size is available in composition before measurement and layout, there's no backwards writes here. And we can call different composables, and that's exactly what the internals of Navigation Suite scaffold do. The layout type is passed through to the Navigation Suite, which is responsible for rendering the UI. And then in here, we render a navigation bar sometimes a navigation rail, sometimes a permanent drawer sheet. So again, now we can achieve the goal of calling different composables based on this window level sizing information. And then we don't run into this issue of backwards writes and first frame correctness. Similarly, list detail pane scaffold works the same way. So the directive here is what is responsible for running the list detail pane scaffold. And the directive is again calculated from the current window adaptive info, which is again the window level sizing information. And this also applies to other state that you have. Any state that you have that's available in composition, you can use to change layouts. There's no issue. It's really the local sizing information that's a problem. This is all I'm going to talk about the Material 3 adaptive layouts here, because I want to dive into custom layouts. But be sure to check out the IO talk to go into more detail about how to use these and how they work. So let's now move on to the last option. And this one is a bit subtle, because if we want to use local sizing information, and we want first frame correctness, and we don't want to use subcomposition, the only option we have left is to make sure that the same composable content is always being called. But how do you do both that and actually implement some of these designs that seem like you need to call different things at different times? And the answer is using more complex layouts. So let's look at an example here that we want to implement. So we want to have two buttons. And if there's enough space to show them side by side with a couple of restrictions, then we want to show them horizontally. And if there's not enough space to do that, then we want to show them vertically. So this means we need to have local size information, because it's about this specific place where we're trying to render this, not like a window level size information. And we want to kind of, it seems like we need to show like a row in one case and a column in another case. So one thing we can start with is something that's a more complicated layout primitive, like flow row. So if we have a flow row and we combine these two buttons, this will get us close to what we want, because flow row will render it side by side if there's enough space to do so. Otherwise, it'll move one down onto the next row, and then it'll be stacked vertically. So this is close to what we want, and this might work for your use case, to use a more complicated layout primitive to get your behavior. But there's some details in here that this won't actually work in our case. Specifically, we want to have that each button should only take up at most half of the width. So if secondary and primary could both fit, but secondary ends up being longer than half of the width, we still want to result in this final one down here. That might be the design requirement that we have. So flow row doesn't really let us do that, to control it that precisely. So in order to get that precise control, we can do a custom layout. So I'll get rid of this flow row, and let's start looking at what this layout looks like. So we have our two buttons, the primary button and the secondary button, that are always rendered like this. And then it's up to us to then exactly place, measure, and decide where they go. So we can do this with the layout composable and then setting up a custom measure policy. So this isn't too bad. We can get the primary measurable, and we get it from layout ID with the primary. We can get the secondary measurable, and these represent the measurables for the two buttons. Then we can actually decide how we want to show them. So the decision about what we want to show depends on the size of them, but we haven't measured them yet, and we haven't placed them yet. So how can we, well, and one other thing is how we actually do want to measure and place them depends on which orientation we want to use. So this kind of seems like a circular issue here, chicken and egg. Like, how do you measure something without knowing how big it is? And the answer is intrinsics. So from the measurable, we can call a min intrinsic width, which will return the minimum width needed in order to render the button correctly. And we pass in here a height, meaning how much height is available to do this calculation. So we can call that for both the primary measurable and the secondary measurable. And then we can check if both of them are less than half of the available width from our constraints. If that's true, then both buttons will fit within 50% of the available width. So if this is true, then we can show them horizontally. And if either of them would be bigger, then we need to show them vertically. So once we know that, we can then keep doing more layout logic in order to decide what to show. So we're now going to set up our primary placeable, secondary placeable, then we're also going to get the width and height of our overall layout. If we're showing them horizontally, then we want each button to take up 50% of the width that's available. We want to kind of fill this space. So to do that, we can set up a half width constraints from our initial constraints, and then force it to be by setting both the min width and max width to this value, set up a half width constraints that we want to measure each one with. So we do that, get a primary and secondary placeable, and then we also need to calculate the height, because the height will be different based on which situation we're in. When we're showing them horizontally, maybe the buttons aren't quite the same height, so we'll take the max of them. Whichever one is taller, that will be the height of our overall layout. And for width, it's up here, since no matter what, whichever case we fall into, we're always going to take up the max width that's available. If we're not showing them horizontally, if we're showing them vertically, then we're going to instead try to measure both buttons to fill up the entire width. And the max width here in the constraints is already the max width, and then we update the min width to also be the max width to force the placeable to take up the entire space. We again measure both of them, and this time the height, since we're stacking them vertically, will just be the sum of the two. So the final step here is to lay out this entire layout with that width and height, and then the placement is again dependent on which situation we're in. So the secondary one here, we're placing on the start. This one we're placing at the end. So that's accomplished here, placing relative. And then the primary placeable we are placing on top of each other with our logic. And this secondary one comes on the bottom, so we render it at primary placeable height, which gives enough space for the primary placeable. So doing that together, this is the result. So we get this behavior, where if there was not enough space to show both side by side, then they're stacked. And if there was enough space, then each one is taking up exactly half of the width. So that's an adaptive layout. That's a custom layout that does exactly the behavior that we want. And if any of these requirements are slightly different, or they change a little bit, you have the exact code that you need to render those requirements. Like this is the precise code to do exactly what you want that you have control over. So that's our first example. Let's move on now to another one. This one is displaying a block of text. But there's another icon that we want to show, and ideally it would be within the last line, if there's enough space. So in this case, we can show the text, and there's enough space for this icon, so we can show it in line at the end. Here, though, there isn't enough space here. So instead what we want to do is we want to show this icon afterwards, kind of make a new line for it at the end. Again, we can do this with a custom layout. And we can use information about the text from the text on-text layout in order to do so. So our custom layout will always be showing both the text and the icon. As part of this text, we're going to save the text layout result up here, and then use that later in our measurement. And this might feel like a backwards write. We're kind of taking this text layout result, we're saving it up here, and we're going to use it later. The key, though, is that we're only reading from this text layout result during the measurement phase, after it's happening. So if I get this text placeable, again, similar to before, we have our text and badge getting the placeables out. Once I measure this text placeable, this will be called, and as part of that, the text layout result will be updated, and therefore, when we refer to it here, this won't be a backwards write. This is a forwards write because we haven't read it until now, and it was measured back here. So we get the text placeable, badge placeable, we can figure out the width and height of the badge, and then we can start doing some layout math. The text layout result gives you a lot of information about the text and exactly how it's going to be rendered. So we can do that by getting the bounding box of the last character from the layout result, and we can get the last character by getting the end of the last line, where the line count is how many lines we have. So the line count minus 1 gives us the last line index. Then, using that and some more math based on the layout direction, we can get the last line relative offset, which is basically the spot at which the last line ends. Then we can do a similar calculation that we did before. If the line ends, and we subtract that from the available width we have, and that's larger than our badge width, then we have enough space to display the badge in the last line. Otherwise, we need to kind of add a new line to the end. So we can have our width, our height, badge x, badge y, and do a bit more math. So if we're going to display it in our last line, then the width will be the width of the layout result, which is kind of the overall width of the text, or it will be the width of the last line plus the badge width that we have, because the badge could extend beyond the text in some cases. For the height, it's kind of a similar calculation. It's either it's whatever is bigger, the overall height of the text, or the height of everything up to the last line plus the height of the badge. And if we're displaying the last line, we're going to be placing the badge basically directly at where the last line ends. Otherwise, if we are displaying it kind of afterwards, then it'll be a little bit simpler because the height is simply like the height of the text plus our badge height, and the width is the width of the layout result, and the badge width, whichever one is bigger, because they're kind of just in different portions of the UI. And then the badge x, badge y is just right after the height of the text, and for the badge x, this will either be the end of the layout that we have of the text, subtracting away the width of the badge, or in some weird case where the text is basically empty, then make sure that we are not going into the negatives. We aren't rendering there. Then we render this whole layout with the width and height we calculated, place the text, place the badge, and with that effect, we get this behavior. And let me actually hopefully run this on the emulator to resize nicely. So as I resize, we have the text wrapping, and then the badge is in the last line, and then on the very case where the kind of text fills up everything, the badge ends up being on the final line, like so. So we didn't have to do any composition here that's different. We're always showing the text, we're always showing the badge, and then we're, with the text layout result, have all the information we need to precisely place it without having to do subcomposition, and everything's right on the first frame. Let's see. I have one more example, which is slightly more complicated, but is based off the text one. So this one is adding a badge, a more button, based on a maxed height of the text. So let's say here that we only want to show 2 lines. If the text is really long, then we may want to show a button to expand it. That was weird. Not the composable code, the UI we want to show. But if we can show all of the text, then we can just show it directly. We don't need this more button. So in order to do this, it's a little bit more complicated, but there's one trick that I want to point out initially. So we're going to always render the text and button, or rather, we're always going to compose them, but sometimes we don't actually want to show the button. So this seems like an issue. How do we make sure that we sometimes don't show the button without having to use subcomposition or that? And the answer is we're always going to compose the button, but we're not always going to place it. And if we don't place it, then it will be composed, but it won't show up in the semantics and it won't show up in the UI. So we can always have it kind of available to place if we need it, but if we run into this situation where there's enough space, we can just skip it and it won't show up. So the layout code for this is a little bit more complicated, but it basically comes down to we'll try to render the text first, and if it fits, we have enough space to do so, and we can just do it. Otherwise, we need to calculate how much text to take away to have enough space for this button, and then render that text instead with the ellipsis. So let's see what that actually looks like in code. Again, we measure and place the text, and then the text layout result that we have from this text is the full text, so we save that. But we're not actually going to render that text. We're going to make that transparent, and we're instead going to draw the text manually from the layout result. So this keeps our semantics all the same. The text is still there in the UI, but our drawing is going to be based on either the full text layout result or the ellipsized layout result. And we're kind of relying on these things, the show button, ellipsized layout result up here, that we're going to set as part of our measurement. Again, this might look like a backwards right. Now, this isn't available in composition, and we're reading this, and it's only going to be set in measurement. But this is the drawing phase. As long as we don't read from these until the drawing phase, if these are being updated in measurement, there's again no backwards right, and we're fine. So we get the full layout text result, and then we can measure the button, and then we're going to decide if we actually need to show the button. And that is the line ellipsized, and again, we check the last line. So if we don't need to show the button, that's actually the much simpler case, because then we just are done. We only place the text, we don't place the button, and then we can just, up here, directly render the text like we would normally. And if we do need to show the button, things get a little bit more complicated, because now we need to do some more math, and we're going to then figure out how much space the ellipsis would take on its own. Then we're going to figure out where in the last line we need to cut it in order to leave space for both the ellipsis and the button. Then we're going to measure again using that information. So now we're going to render the text that is a smaller bit of the initial text. And we're going to save that to be drawn above. And then this code is very similar to the button code from last time to figure out where to actually place the button. Based on that new layout result, the bounding box of the last character, and then we can figure out exactly how big and where to place the button. This is pretty similar. We're always going to fill up the max width. The height is going to be the height of the new layout result, and the button plus the last line, whichever one's bigger. And then we're going to figure out where to place the button right after the last line. So putting all of that together, what we get is something that looks like this. And let me run this on a resizable window here. I didn't click the right one. So here is what we get. So here we're only rendering 5 lines, and then we're ellipsizing. Then if I start dragging, the more button goes away, because now we can actually render all the text in those 5 lines. And then if it's smaller, we'll always only have 5 lines, and this more button hides and disappears as we desire. So this is an example of how can you meet always having the same things in composition with the text and the button, but by skipping placing one, we can actually remove it from the UI if we don't need it. So that's a way to kind of get around that issue, still have first frame correctness without needing subcomposition, using the text layout info, and without having any backwards writes. So that's the third and most complex example. So hopefully you were able to stick with me for all of that. And I want to pull it back now to kind of a flow chart here of how you can approach building these different designs that you might have that meet all of our criteria and work well. So if you don't need local size or position, you can just use the window size, other state to influence composition. If you do really need local size, then check to see if there's an existing layout primitive for that behavior. You can use things like flow rows, lazy vertical grids, things like that that already do this for you, have built-in behavior. If there is, just use that. If you do need to call different composables, there's nothing inherently wrong about box with constraints or subcomposed layout. It gives you the information that you have, and you can call different composables. Just be careful about subcomposition. And if that is a problem, then the last option that you have is using a custom layout. And these aren't that bad to do. They give you exact access to do the math that you need based on a design to get a certain effect. And if you isolate it to that kind of trickiest bit of like precise behavior that you want, in a custom layout, you can write exactly what you need, and then you're happy. There's the design. So that's the solution based on kind of the phases and how that restricts you in Compose. It can be tricky at first to kind of implement a design while following all those steps, but with them, you can then have these layouts that meet the design requirements and also don't run into some of those flakiness or flickering or other issues. Thank you very much.